So today in this session, I'm going to discuss about how we can expose the gRPC services with confidence via Kubernetes clusters. So in this talk, we will go through first the major pain points while exposing the gRPC services for external users. Then we will see what are the problems the developers and team see in day-to-day life. And then we'll look up for the open source solutions available in the market. And then we will go up to a brief architecture overview of that solution. And then we'll go for use cases and we'll see the live demo of how we can expose the service in Kubernetes. So no doubt about it, gRPC services are production ready, but when it comes to expose it for external users, it seriously poses a risk for it. A risk in the sense, if we expose it for external users, we need to make sure that we apply a proper authentication mechanism over it. Maybe OAuth, JWT, basic authentication, and maybe other. So that's the main thing we face while exposing the gRPC services. Second thing, some organizations have their own policy to put some rate limiting over gRPC services. Maybe they have to put a throttling policies and other policy as well. So it become a bit difficult to impose all these policies over services. And sometimes some big organizations have some policy, governance policy, and they want to intercept and engage some mediations in the request flow and the response flow as well. So it's become a bit difficult again to manage all these things, because at all the time we cannot go to the backend team or the service team to and ask them to implement all these services, because it's a bit difficult for them as well. And at last, if we expose the services at large scales, then definitely we have to manage the life cycles as well. Sometimes the APIs are in the production, sometimes API in the deprecate, sometimes it's retired on the other life cycles as well. And definitely while managing the life cycle, we need to make sure that we are managing the versions as well. If we have this much of problems, if we try to fix all these things from the backend side, it will be a bit difficult for us. So, and especially in the Kubernetes environment where we are running with a lot of nodes, where we run a lot of pods inside of clusters, so it becomes hard to manage it. And so, is there any open source solution available in the market? So yes, there is one open source solution available in the market, which is a APK. So APK stands for the API platform for a Kubernetes. It is natively designed for a Kubernetes environment, and it's completely an open source tool which adheres the microservices architectures and completely built on the top of Envoy Gateway and utilizes Java as a primary language. So this product or tool APK utilizes the major key components of the Kubernetes like namespaces, clusters, custom resources, pod, and everything, and it knows about how to deal gRPC services in the Kubernetes environment. So it's more like you can create your own custom resource like YAML files and configuration files, and you can simply apply it to your Kubernetes clusters and expose your services easily. So if I talk about the architecture level, so this tool is majorly divided into two layers. So first one is more about control plane, and second one is a data plane. So control plane, we can treat it as a main portal which is responsible for deploying the services, creating a API, deploying the API, creating a policies, rate limiting policy, throttling policy, creating an interceptor, mediator or mediation flow. We can create with the help of this control plane and can deploy these things to the gateway. So other side, data plane is more of handling a real-time traffic, handling a request. Whenever the request comes to the gateway, data plane get engaged, it checks whether the security has been enforced over a request or not. And after checking all these things, it's checked whether the rate limiting has been there or not, any mediation policy has been engaged in the request flow or not. So if it is there, they engaged it. If it's not, it's bypassed and passed through the request to the backend services. After the backend services respond back to the gateway or data planes, it again checks if there any mediation policies are present in the response flow. If it is there, it tries to engage those policies and simply return the response to the client. So that's how this two major component of the APK. So if I talk about the architecture view, so this architecture is more focusing on the gRPC services for the deploying the gRPC services. Here we can see that this is the API developer. First, API developers needs to have some proto files, and with the help of that file, it will generate some sort of a APK configuration, which is adapted by this APK. After getting those APK configuration, we can call the REST APIs, which is a control plane REST APIs or custom resources to deploy those API. And after this changes, there are information or the APIs is available over the gateway, and the users can easily consume it and usually use it. So at the rightmost side, you can see that we have a microservices or a backend, we can call it. So when the request comes in, it comes to the data plane. Data plane check all those information, then pass to the request to the backend or microservices, and get the response from it and return back to the client. So that's how the architecture works like, the major flow of this APK. So if I talk about the deployment architecture, so definitely if we are using a gRPC services in the Kubernetes, then definitely we need to make sure that we are taking care of a scaling point of view as well. So as I mentioned that this APK is completely adhere the microservices architecture. So we can clearly see that there is a two components. The first one is the control plane, other one is the data plane. So the scaling has been done in two major parts. So first is when you have the huge numbers of requests incoming to your gateway. So suppose today you have 10, tomorrow you have 100 requests, or maybe so on, 1,000, 10,000, so on. So yes, the horizontal scaling is available in this structure. So you can just simply use HPA kind of horizontal port scaling and scale up your environment easily. So that's how you can scale up when you have a huge numbers of requests incoming. But what if you have a huge numbers of API count, maybe 100,000, 10,000? So in that manner, you can scale up the data plane control plane as well by doing the gateway partitioning. You can partition the gateway and select which API needs to be deployed on which gateway. So by that way, you can do a vertical scaling as well. So this APK or this open source software cover up all the scaling point of view. So that's the thing. And if I talk about today demo scenario, so what we want to do is we will be going to create one Kubernetes clusters, and over that we will deploy one backend, and we will try to deploy the API service, gRPC services with the help of the REST API, and definitely we will try with the custom resources as well, which is basically a YAML file, and later on we will try to enable and disable the security mechanism of the services, and then we will configure some rate limiting policies as well, and at the end we will try to modify the headers as well, because if you go to the banking sector, they have their own set of governance policy, and they don't want to, they don't want to take authentication barrier token in the authorization header. Maybe they want to take in some other header. So you can do that kind of changes as well with the help of this tool. So I'll quickly share my screen. So before we start, I will show you that I have already set up this APK, Kubernetes APK in my environment. So these pods are running. So you can simply use the Helm chart. So this tool has the nicely written Helm chart. You can simply use and apply it to your Kubernetes clusters and make it running available. So just for the information, I have created one more service, which is order backend service. This is just nothing, just a backend service.
Can you make a size bigger so that people can?
It's okay. So firstly, we will try to deploy the API. So I have written some set of curl command, which I will explain how we are going to do it and how we are using it. So firstly, I will try to generate the APK configuration with the help of the protocol file. So I'll simply make a curl command to the API host and get the order APK file. So this file contains of some information about what are the targets, what are the API type. Here you can see that the API type is named as a gRPC. I'll quickly rename it as a and provide ID as a order service. So here you can see that I don't have any backend information or endpoint information available here. So I'll quickly add my endpoint information as well. So this is the backend which I have mentioned in the early that I have created it for this demo. So I'll save this API, and to deploy the API, first we need to have a JWT token. So you can generate the token with the help of client ID and client secret. So this is the client ID and client secret. I have already created those secrets. So utilizing that JWT token, I will simply deploy the API with the help of this endpoint. Okay, now my API has been deployed. I will quickly check if that API is available. So you can see that my API has been deployed. So I will try to invoke that API. So again, I will generate a token if I want to access the API. Definitely I need a token, JWT token. So I will quickly generate that token, and utilizing the gRPC curl CLI tool, I will invoke that API. So this is my gRPC curl tool. I will simply replace the token. So it's asking me the common protobuf file, so I need to unzip the directory which consists of this file, protobuf file. So if I try to invoke the API now, I'm able to get the response. So what I have done is I have simply created an API with the help of the definitions and then generated a token and then simply invoked the API with the help of that JWT token. So next we will try to deploy this API with the help of custom resources. Custom resources is more about the configuration YAML file. As we have just deployed the API with the help of the REST API, now we will see how we can deploy it with the help of custom resources. So I'll quickly delete this API. Yeah. Okay, now the API has been deleted. So I will generate the KTS resources with the help of the another endpoints by providing it our protobuf definitions and our APK configuration. So it will generate a YAML file for Kubernetes YAML file for us. Okay. If I see the file is there, so I will unzip that file. After unzipping it, I could see that all the services are available here. So I can see that the API is there, order service, all the routing I can see it here, and all the rules are available here. So if I want to deploy this API, again I can just simply go and put the apply command and can deploy the. If I check, my API is there. So that's how we can deploy the API. So next we will see how we can disable the authentication. If you want to disable the authentication, you can simply provide a kind of a rule here. So it's more of this rule here. You can create simply rule. I have already created a rule. You can see this authentication rule, and I have disabled it here as a true. So if I go and now if I try to invoke the API, I should be able to do it without providing a JWT token. But for that, I'll first delete the API and can quickly deploy it again. Okay. So now if I try to invoke the API, I should be able to invoke it insecurely as well. Okay, it's showing that we are provided. I think we need to okay, we need to apply it with the help of this APK configuration. We cannot apply this with the help of this YAML because I have made changes with the help of this. So that's how we can simply create a rules and we can simply apply it to the Kubernetes clusters and can delete those informations as well, or can remove the authentication part. So now we will see how we can apply the rate limiting policy. For the rate limiting policy, it's applied over different levels, at resources levels, at the single API level, or at the global level as well. And you can create your own configuration as well and can apply the custom rate limiting policies as well. So in this, I have defined a unit 2, so 2 requests per minute. So I'll go and apply. Okay, now my policy has been created. So if I try to invoke that API again, let me check if my API has been deployed. Okay, my API is there. So here you can see that after 2 successful times, the API has been throttled out because we have defined a 2 requests per minute rule. So it has been disabled now. So after 1 minute, it will again unblock and we are able to utilize it like a normal way. So as I mentioned that with the we can make some changes in the authentications header as well. So we can just simply need to define another rule in the APK configuration file. So here if we applied it like this way, so now the authorization header needs to be passed as a test auth, not as a authorization. So here I need to change it like this and then I will be able to invoke it. So I'll show it as well. Now you can see in the definition as well the header has been changed and now it should expect the header in the test auth. Okay, I think we need to generate a token again. Maybe some steps we have been missed, but anyway we can change the headers and we can do this way as well. So yeah, that's all about it. Any question?
Where is the documentation of this?
This is available over the GitHub as well, and you can access the WSO2 APK configuration and you can try it from there as well.
So the APK creates a CRD internally.
Yes.
And then we're applying or even the gRPC APIs.
Yes. By that way only it will be happen.
So if you want to push to a CI/CD.
Yeah, you can integrate those pipelines as well, and they have support of the CI/CDs as well. You can define the YAML file and can utilize it to make any changes. If you make any changes to the API, maybe you want to make a change of name, you can do a continuous integration for that as well.
So you mentioned about it's also through the Helm, right?
Yes.
So have you?
I'm not sure much on this, but it's like we can have a different way to handle this, and there are their own set of commands to do this kind of changes.
So recently Helm 4 has come out.
Yes. Yeah, it support Helm as well. It works with all the Kubernetes versions, and it supports the latest Helm as well. So
Does it also provide kind of a dashboard for
At the moment, it's in the development phase, so the dashboards are not been available. It's completely CLI at the point. But yeah, the further development has been done to do a more on this. Maybe in future, maybe we have dashboard for it as well.
So, talking about the APIs, what has been deployed?
Yeah. So at the moment, as we develop anything, we first need to build the API. So API part has been done. Now they are more focusing on to build the UI as well. Yes, user friendly as well. That's it.
Thank you.
Thank you.